Hi friends, welcome back. Coming to the next topic, that is the Bresenhams line algorithm. So in the previous video, I explained how to write the algorithm and what different examples on the DDA algorithm. Now let's see the Bresenhams line algorithm. So this is also a scan conversion algorithm, the scan conversion method to draw the line segment. Okay, so it is scan conversion method for drawing the line segment. Now let's see, what is this Bresenhams line generation algorithm? Actually, it is an efficient method than DDA. We call it as an efficient method than DDA because it involves only integers. Let me write. It is an efficient method. Why we call it as an efficient method? Because it involves only integers, like additions, subtractions, and even multiplication operations. Okay, and these operations can be performed very rapidly when compared to other algorithms, and these operations can perform very rapidly. So the lines can be generated quickly. Because of performing rapidly, the lines can be generated very quickly. So this method, next pixel selected that or who has the least distance between the true line. Okay, so whereas if you take the DDA algorithm, how the next pixel can be identified? By taking the help of the previous pixel. Okay, with the help of the previous pixel, the next next pixel can be identified. That's why we call it as DDA is an incremental approach. But here in the Bresenhams algorithm, it uses the least distance, the pixel that is present between the least distance between the true line. One true line that will be present. So this is a true line. In this true line, which pixel will be the nearest one? Okay, so which pixel is the nearest one? That pixel has to be taken. So that is the Bresenhams line algorithm. So we call it as an efficient method when compared to the remaining algorithms. Okay, so let me explain how you are going to be selected the nearest pixel to the true line. So exactly what is a true line and what are the pixels? How can you calculate the distance there? Okay, how can you make a one parameter is a perfect parameter to the true to accept that? Okay, now let's see. Let me take for a given value of x. Let me write that point. First step. Let me take for a given value of x, one pixel lies at distance t1 above the line. Okay, let me take one pixel at a distance t1. So first let me show you, this is a graph. Let me take this as a graph. Okay, so here if you take this is a start point, this is a starting point, it's a start position. Let me take this is a start position, this is a start position. Here did you observe here a 2 will be there? So one is a pixel that is present below this line and above this line. If the pixel that below this line, you call it as a B coordinate. Let's take this is the above the line, it's a A coordinate. And this you call it as a true line. This you call it as a true line. So from start position, we have to decide A or B. Which one is the next pixel? So this pixel or this pixel, which pixel is the next pixel? That we have to be find out. So for that, you have to see this. For a given value of x, let's take one pixel lies at a distance t1 above the line distance t1. Let me take. So this is one of the important topic. Just please keep the concentration here so that you will understand what is this Bresenhams algorithm. Okay, so this is a pixel let me take a true line is there. So this is a true line, a straight line, you call it as a true line. So these are the pixels. So here the first one, for any given value of x, one pixel lies at a distance t1. So here one, let me take, this is a point, at an intersecting point. So one pixel at a distance t1 above the line. This is a t1 above the line. And another one pixel lies at distance si below the line. So here one more pixel is there. So from here to here the distance is t1, and from here to here the distance is si. So which pixel I need to be take as a coordinate, okay, to draw the line segment. So here the pixels are seeing very far, but all this clubbed into only single pixel here. Okay, it's I written the graph very big, so whenever you are seen on the screen, a pixels is very, very small. Okay, so here the distance between above the line is the t1 distance is there, and below the line it's si distance is there. So which you need to be take. So for that a decision parameter will be decided, that is decision parameter. What is a decision parameter? The decision parameter is the exact point that it will use to find draw the line on the graph. di is equal to si minus ti, below line minus above line. The distance between the below line minus above line, you will get the decision parameter. Okay, if di is less than, let's take if the decision line is decision parameter that di is less than 0, then closest pixel, what will be the closest pixel if di is less than 0 means below the below the line, means closest to the pixel is below true line, then si is smaller. Means you can take si because it is closest to the true line. Suppose if the decision parameter di whatever you are taken is greater than or equal to 0, then closest pixel is above true line. Means that close above the true line there is a closest pixel, then you have to take ti, because ti is smaller. So based on the decision parameter you can take si or ti. So if it is less than the decision parameter, whatever you get that it is less than 0, you have to take that pixel is si below the line, and if it is greater than or equal to 0 you have to take ti, because ti is closest to the true line. The pixel that is closest to the true line, that pixel you need to be take. That is a concept. Okay, so we must calculate the new values for di as we move along the line. So this is an introduction part. Okay, so the thing only, don't confuse, the thing is you want to draw a true line. So in between that so many pixels are there. Okay, whatever the pixel that will be. So which pixel I have to take, based on that I can reach this true line. So here A is there and the B is there. I want to reach this B line. Okay, that should be a straight line I want. So if I want a straight line, which pixel help I need to be take? So above the true line is a ti and below the true line is a si, the distance. So based on this decision parameter I can take si or di. Okay, so in the next video I'll explain this Bresenhams algorithm with an example. Thank you.